All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going through the course technology text, JavaScript's 6th edition, and I'm up to Chapter 7, which is kind of a break from what we've been talking about, a lot of what we've been talking about previously, and that is we're going to talk about object-oriented JavaScript. Remember that earlier I mentioned that JavaScript is what's known as an object-based programming language. And what that means is that JavaScript has full object-oriented programming, or OOP as it's known, functionality which you can choose to use or not use. And so far we've used some, but not a lot. We've used things like document.write, which is the write method of the document object. All right? We've used things like window.alert, or just alert, which is from the window object. So we've looked at a little bit of this. But in this chapter, amongst other things, we're going to talk about defining our own objects. So, first for our objectives, we want to make sure we're explained the basic concepts related to object-oriented programming. There are examples in the book. I'll give my own examples. We'll talk about some of the built-in JavaScript objects, those including date, number, and math. And then we'll learn finally in the end how to define our own custom JavaScript objects. All right? So one of the things about object-oriented programming is they mention right here, reuse, code reuse. And typically whenever you talk about code reuse, the ability to reuse something, then you're talking about saving money. So object-oriented programming has always been the kind of term that has piqued the interest of management. But another thing, and I don't know if it's going to be in here or not, but I'm going to mention it, is what you're doing when you're working with object-oriented programming is you're modeling. For instance, if you live in a town and they decide that in that town, let's say you've got a high school, and they decide that what they want to do is they want to build a new football field for the high school. And it'll be able to be used for football and maybe for soccer and maybe for other things. They're probably not just going to break ground and start to create the football field. Rather, someone is going to build a model of it. People will pick apart the model, talk about what works, what doesn't work, etc. And then they'll come in and start actually making changes. All right, adding, doing whatever it is they're going to do. So, again, object-oriented programming is all about modeling and about reusability. Okay? Now they talk about an object here. Before we go into objects, let's talk about what an object is a part of. Okay? So an object is what's called an instance of what's referred to as a class. And a class is a blueprint. So in other words, if I created a class and I called it person, all right? And then I could sit there and start saying, well, every person has a first name, a last name, a height, a weight, a gender, an eye color, a hair color, although when someone is bald, as I'm getting to be, I don't know what you put down for a hair color, all right? But when you create that, what you're doing is you're creating a template or a blueprint. And that's pretty much what a class is. From that class, you create objects. So I could create a person object named Jeff that was going to represent me, as an example. I could create another one for my wife and call it Sandy. All right. So as it says, with object-oriented programming, with an object, all right, then as it's mentioned right here, the code and the data are one individual unit. Okay? And really, what they've called an object here, I would call a class, because what an object is it's an instance of a class. When you create an instance of a class and make it an object, that instance of a class, when you instance a class, it's known as instantiation. That's exactly what you're doing. So the object holds code and it holds data. All right? The code that it holds is typically referred to as a method, and it describes behaviors or different things that any object of that type of class can do. Data is called attributes, and it's kind of the characteristics. So again, as I mentioned before, if I made a person class, I would give it data like height, weight, gender, eye color, hair color, etc. And I would give it code or methods for maybe eat, drink, sleep, etc. All right? So many programming languages that are out there today, and there's a couple of them listed here, are object-oriented. All right? C++, C Sharp, Java is an object-oriented programming language. Usually you don't even talk about Visual Basic anymore. You talk about Visual Basic.net, which again is an object-oriented programming language. All right? So again, notice what you do with object-oriented programming is you end up combining your own objects with objects that other people create, and there might even be some built-in objects from someplace, and you combine all that together, and that's what ends up becoming your program. All right, some more terminology regarding objects. First, they talk about encapsulated objects, okay? And it says the code and data is contained within the object itself. All right, if I come in and I decide I'm going to click File here, and I'm going to go to Print, and I'm going to bring this thing up right here. I'll enable printing, etc. But, oops, hopefully I didn't just send that to my printer. But if I come in here and I do a file, let's try it again. Print, okay? And if I decide when I do all this stuff, I'm going to click the button that says print and actually print this. I don't know what physically happens between the time I click print and the time I walk over to my printer to pick up the copies of this. I don't know what happens, and to be honest with you, I don't care. That's been hidden away from me or encapsulated from me as far as what's going on. All right? In much the same way, if that confused you a little bit, then think about it this way. All right? And that is, you get up in the morning, and let's say that you're going to go to work. So you get up in the morning, you do whatever you have to do to get ready. You eventually, maybe you shower, put on a change of clothes, maybe eat breakfast, but hopefully, probably I should say, eventually you'll get to the point where you get in your car. So if you get in your car and you're not backed into your garage or your driveway, you put the car in reverse, you lightly hit the gas, and you start moving out. Well, the reason I'm telling you that is most people couldn't tell you what happens internally in a car when you go and take, your foot's on the brake and you shift it from park into reverse. And most people don't care. They just care that when they shift the car into reverse, that it goes backward rather than forward. So what encapsulation does is it places code into what's typically known as a black box. And what they mean by that is that black box, you don't have to care how something is done. You just care that something is done. Not so much how. You care what is done, not how it's done. And going along with that is this principle of information hiding. As it says, anything that the programmer does that other people, other programmers or anybody else doesn't need to care about or directly work with should be hidden from them. All right, you want another example? I'm dating myself here because I know we don't use these much anymore. But back in the days when we had the VCRs, and you plugged in your VCR, it sat there and it blinked 12 o'clock, 12 o'clock, 12 o'clock, 12 o'clock, 12 o'clock. And typically you hit a button or two and then you could reset the time. I don't know internally exactly how that time was reset, and I don't care. What I saw was the interface. I saw that 12 o'clock blinking. All right, and then I saw a button on there that said maybe reset time, or one that said hours and one that said minutes. And I, through trial and error or maybe looking at the manual, all right, I could tell by the interface what I was supposed to do. But the actual code itself that you hide with information hiding, that's typically referred to as the implementation. So the interface is what you show the outside world. The implementation, all right, is what you hide from everybody. So why do you do that? Well, you encapsulate or you hide these things because it reduces code complexity, it prevents accidental bugs, and it prevents other people from stealing your code. And another example here, good example. In fact, I've used this one in the past myself. So I come in here and I go to calculator and I type in 573 and I click the button that says square root. All right, and it tells me that the square root of 573 is 23.93 something. I don't know what happened between the time I put in 572 or 573, I should say, and then click that button, and I don't care. All I care about is this right here, which is my interface. I knew I had to type in my number, and I knew when I got done I had to click that button, and I knew when I was done from that, it would give me a final answer. All right, so again, that's what I care about. Well, as it says, the document object is another thing that is actually encapsulated or put into what we'd call a black box. All right? And we'll talk about the get element by ID method, etc. in a little bit. All right, so I mentioned classes to you. I would have done it first, but hey, it's not my book, and there's absolutely nothing wrong with the way the author did it. When you combine the code, the methods, and the attributes that will eventually make up an object, you create a blueprint of what the object should look like. That blueprint is the class. If you're still confused, look at it this way. Imagine that I've got a lot, a vacant lot, and that lot is 100 acres in size. And I decide that on that lot, I'm going to place 100 homes. All right, and I have 5 house plans. So I'll have house 1, 2, 3, 4, 5, then the next row 1, 2, 3, 4, 5, etc. Each one of those house plans, if there's 5 of them, would be a house plan class. Each time I create a house based off of one of those house plans, it's an object. Now, each object could have different things as far as I could have 2 houses that looked exactly alike, but maybe one was sided and one was not sided. Maybe one had brick on it and one didn't have brick on it. Maybe one was painted blue and one was painted white, etc. So they'd be basically the same house, but some of their attributes would be different. All right? So again, when you instance or you do instantiate or instantiation, that's when you create an object from a class. So when you create an object from a class, the object automatically inherits or gets everything the class had. It says here, objects in the browser object model, or the BOM that we talked about previously, are part of the web browser. So you don't need to create them. They're just available to you. So here are some built-in JavaScript classes. And these are shown in your book. Table 7.1 on pages 457 and 458. All right, so these are built-in JavaScript classes, which means you can use them. All right, we'll see some examples as we go on in here. As it says, some objects you can use directly in code. Like you can use the math object, like this is shown right here, and you don't have to create a math object. So you can use the math class, I should have said. You can use the math class without even creating a math object. It's legal to do that, and they're showing you how to do that right here. Rather than creating an object of the math class, you just use the math class directly, dot, whatever it is you want to do. Some objects, though, require the programmer to create a new object. All right? So, for example, if you use an array, you've got to create an array object. If you use an object itself, you create an object. All right? Same thing with a date, and they give you some examples here. Now, this concept here that's referred to as garbage collection, I wouldn't let it worry you too much, but this is how I define garbage collection. All right? Not everyone might agree with what I'm about to say, because really most every type of software package handles garbage collection in a little bit different manner. But this is what I do. I liken garbage collection back when I went and got my 4-year degree right out of high school, which seems like years and years and years ago. All right? And it was around 40 years ago. But right out of high school, I went and got myself a journalism degree. And while I was going for my degree, I went to the University of Wisconsin, Milwaukee. All right, and while I was going there, the campus is very spread out. All right, so it's on several acres. It's on actually several blocks. It's interspersed with houses, and there's some restaurants and some other stuff there. It's changed a lot since I went there, of course, but that's the way it was then. And the point is that quite often at the time when I would go there, what I would end up doing is I'd park on the road. And the tough thing was it said 2-hour parking. So what would happen? Well, typically what would happen is some kind of a meter maid, man or woman, it doesn't matter, on their little cart or on their little scooter would come by, and they would put like a chalk mark underneath your tire. Then they'd come back again 2 hours later. If the car was still there and the car had a chalk mark on it, they knew they could ticket you. All right, it'd probably come over a little more than 2 hours, but you get the idea. All right. Well, with garbage collection, typically what happens is the garbage collection runs under the operating system. Okay? So what happens is a similar type of thing. You stop using something in JavaScript or whatever, but let's use JavaScript. You stop using something in it, and the garbage collector comes by and says, "Wow, this isn't being used." So it flags it, which is, again, similar to putting the chalk mark underneath it. Then when it comes around again, if that chalk mark is still there, they say, "Oh, okay, no one's using it," so it reclaims that memory that was being used by the program. All right. Now it says JavaScript knows when a program no longer needs a variable or object, and it automatically cleans up memory. There's no one that I know of that can tell you exactly how that works, because since it works under the guise of the operating system, it's just something that happens. All right? All right. The next thing that's discussed in here, and it looks like it's going to be trying to figure out the page that starts on, but no biggie. All right, the bottom of page 463, using date, number, and math classes. As mentioned, these are 3 of the most commonly used built-in JavaScript classes. So the first is the date class. All right, and as you can see in table 7.2, which is on the slide here, and page 464 in the book as well, some of the date class constructors. What's a constructor? When you create a new object. So when I do this, if I come in there and do this, and I say var date equal new date, like that. All right, what happens is when this is called right here, it calls a built-in constructor, which means it's a function that runs when you first create the object. If I don't add anything here, what should happen is date should now hold an object with the current date and the current time in it. All right, that's what the default constructor will end up doing for me. Now remember that when you work with object-oriented programming, everything is methods and properties. So the constructor is a special type of method. All right, it's a behavior. So it's a special kind of method that gets invoked automatically when the object is created. All right, so you can call just the date. You can call the date and ask for the answer back in milliseconds. You can pass it a string. You can pass it a year, a month, and a day, etc. So there's different ways that you can call the constructor. What's shown on the slide right here in that first example of our today equal new date is very similar to what I gave you. So it'll automatically give you a brand new date, and I believe it'll give you the month, the day, and the year, and then the hour, the second, the minute, and the millisecond. But you can provide things like this. Notice we passed Independence Day. All right, so we created a new variable, I should say, called Independence Day, and to a date object, but we passed it in a year, and a month, and a day. And you might look at that and go, you know, that's wrong because it's wrong because the first month of the year is January, so the sixth month would be June, and Independence Day isn't June 4th, it's July 4th. Yeah, but remember again, since we're programmers, when you start counting the months, month 0 is actually January, so month 6 is July. All right, after you create a new date object, you can manipulate it because there are built-in JavaScript methods that you can use on this object. Notice when you create a date object, it's not a clock, so the time stays. The date and the time stay, they're not changed. But what you can do is you can create a couple different date objects or one date object, and you can run some of these methods on it as shown in table 7.3, which is here in the next two slides. So I can pluck out the entire date or just the day or just the year or just the hours, etc. Anytime you see these get things, they're called accessors, and what it's going to do is it's going to provide you what you ask for. If I'm in class on the first day and the first student walks in and says hi, and I say, hi, what's your name? And it's a young lady and she says, Mary. Okay, now what I just did was I did a get name for her. I didn't do a set name. I didn't say, no, your name's not Mary. All right, probably when Mary was born at the hospital, her parents may have been asked, what are you going to name her? And they said, Mary. That's a set. But a get is called an accessor. It's when you just get the information. Notice there's also a now, which gives you basically the current date in milliseconds since what's called the Unix epoch date, which is January 1st, 1970. So not only are there a bunch of get functions, there are a bunch of set functions. They're not the same, but many of them are very similar. So you can do different things with the date. All right? Here are some examples. Again, notice get day. Day 0 is Sunday. I know it's a little strange to think about. We talked about that before. It's just the way that it is. Okay, so if you notice in here, we've got var today equal new date. Then we come in and we create an array of strings. So this would be month 0, month 1, month 2, etc. So the current months would say, well, look in there and do a today.getMonth. So if it was January, it would come back with 0. If it was December, it would come back with 11, etc. All right. Now, there used to be a really good website, and there are tons of really good websites out there, but there used to be a really good website, and I believe it's still down. It's been down for half a year, so I don't think it's ever coming back up. It was called hunlock.com, and still get the error message. But what was so nice about it, this Hunlock site, and it's not Hunlock Creek, it's not a town, is it was all broken up and it had all sorts of stuff, all right, on the different JavaScript classes. So let's say JavaScript date class. All right, so we can go to W3 Schools, we can go to the developer Mozilla site, etc. So there's a lot of really good places that you can go to get information. Developer.mozilla.org is really good. All right. Notice there are all those gets and sets that we talked about. So you can do that, and you can punch in date. Next, we're going to talk about number. And you'll notice we can get all the number stuff. All right. So if I jump into that right now, the number class, as it says, it has methods for manipulating numbers and properties. Here are some of the things that you can use. I'm not going to go into any of these at all. Nothing that's here. In fact, let's talk about one. Just one. The second one here that's called toFixed. I don't know if you remember, but earlier we set up a program where we made a simple type of calculator. And when we had something like var x, we didn't use x, var like number 1 equal 37, var number 2 equal 13, and then var result is equal to number 1 divided by number 2. Okay, so that would give us 37 divided by 13, which is 2 point something. I'm going to just make this number up, but let's assume we get the answer of 2.456789, something goofy like that. Well, maybe I don't want all that stuff. Maybe I only want this to 1 or 2 decimal places. So what I can do, there's nothing wrong because the correct answer, the technically correct answer is right here. But I can say do this. All right, so notice I'm putting it in parentheses. Do this division, and then when you get the answer, do a dot, toFixed, and do it to 2 decimal places. And what that'll do is it'll say, okay, we've got all this. We want 2 decimal places. Then it looks at the second one that's right there, and it says, is this greater or equal to 5? And it is. So the answer we're going to get now, instead of 2.45678990, will be just 2.46. All right, so that's an example of using one of the methods of the number class. And probably it's the one you're going to use the most often. There are other ones. Again, the primary reason it says for using any of these is to convert from a string to a number or a number to a string. Other things, some class properties for the number class. Max value is the largest positive number that you can use. Min value is the smallest number you can possibly use. You know NaN is not a number. And you can have infinity, either on the negative or on the positive side. It's a good example. All right, performing functions in the math class, that's the kind of thing that you typically use. All right. So here are some of the major math functions. Now, some of them, like sine and cosine and etc., some of them are trigonometric functions. So you might never have reason to use those, or you might, depending on what it is, what job or whatever it is you're working with or for. All right. Some of the other ones you might have reason to use a lot. One that doesn't get used as that much, but really should, is the absolute value function. If somebody says, let's say the 2 people meet on the street, all right, and they know each other, but they haven't seen each other for years. We'll say that it's Bob and Sue. So Bob says, Sue, is that you? And Sue says, yes. And Bob says, wow, we haven't seen each other probably in a good 20 years. And Bob smiles and says, I just celebrated my 50th birthday. And Sue said, really? I just celebrated my 40th birthday. Well, if Bob is 50 and if Sue is 40, there's 10 years between them. Really doesn't matter if you say 50 minus 40 or 40 minus 50, because we don't care about negatives here. That doesn't make any sense. But either way, what we're saying is there's 10 years between them. So what the absolute value does is it says if you try to do something and you get a negative number, just make it positive. All right? I already mentioned the cosine, the sine, the tangent, etc. All those right here, those are trigonometric functions. The ceiling rounds up to the highest number. So even if you have 7.1, the ceiling of that would be the next highest number, which would be 8. Cosine is another trigonometric. Exponentiation, you may or may not use. Floor is the opposite of ceiling. So if I said the number was 7.9 and I asked for the floor, it would be 7. Max and min can be used to find the largest number or the smallest number. Pow is used to raise things to a power. So if I said math.pow and where I've got the xy here, I put, for example, 4, 2. That would be 4 squared. 4 times 4, or 16. Random is used to generate a random number, often used in game programming and in other things too. You might need a random number. Rounding does just that. It'll round to a certain number of decimal places. So when I did that 2 fixed before, I could have done a round also. But typically when you're working with numbers with decimals, you use the 2 fixed. The sine and the tangent that are in that list, again, are both trigonometric. And the square root we already looked at to find a square root value. So these are some of the methods. Some of the properties are shown right here. Again, most of them, other than possibly pi that you see right there, most of the ones that are in here are used in more, not in business calculations, but if you were doing something in the scientific realm. Also notice that E and ln, 10, etc., and pi, they're all constants. They're all constant values. That's why they're in uppercase like that. Here's an example then of using math.pow. There's a math.pi. There's a math.round. Okay? All right. Then let's get to what's new. And that is, we may want to create our own objects. All right, so starting on page 490 in the book, on page 490, they start to talk about building your own custom JavaScript objects. All right, so notice, unlike Java and unlike C# and some other object-oriented languages, JavaScript, as we mentioned, is not a true object-oriented language. You don't create classes in JavaScript. You create objects because it's object-based. All right, you can define custom objects. Okay, and we'll talk about that in just a bit. There are different ways that you can create a custom object, and 2 of them are shown here. So if I wanted to create a person object, I could say var person equals new object, paren, or I could say var person equals and just put curly braces. That's not what we did before for an array. For an array, we used brackets. All right, here you use, for an object, you use curly braces. Once you create an object, you can assign your own properties to that object. Okay, so if we created an inventory list object, we could create an inventory date. All right, that would be an attribute of an inventory list object. We create it by creating a new date. As it says, you can assign values to properties of an object when the object is first created. So notice we're trying to create kind of a object here, and we're saying that the name of the object is performance tickets. It has a customer name, it has a performance name, it has a ticket quantity, and it has a performance date. The customer name is Claudia Salomon. The performance name is Swan Lake. The ticket quantity is 2. All right, and the date, not sure how they're exactly setting that up in there. The year is 2017. Probably that's the month and the day, and that might be the hour. So remember, 6 is really July, so July 18th, and 20, if that's the hour, that would be 8 p.m. Could be wrong on that. So you could have an object like this that contains another object inside of it. So here's an order object that contains an order number, then another object inside of it called address, which is made up of street, city, state, and zip. Again, most of this stuff is only limited by your own imagination. Now, when we talked about arrays in an earlier chapter, when we talked about arrays, remember our arrays were always indexed by numbers, but they don't have to be. In JavaScript, you can also have what are referred to as an associative array. Let's look at a real simple example of what that is and why you might want to use that. All right, so let's say that I came in here and I created a new array. Hopefully you remember this, but I'm gonna put five. We'll put 5 elements in it. Okay, we're gonna call this var. This is gonna. I just got hit with this. I don't know why, but I'm gonna call this mstates, and I'm gonna set that equal to, and I'm gonna put in brackets here, Michigan, Missouri, Montana. What are some other M states? Maryland, which I guess should have come back here if I'm trying to make this. Maryland. All right, did I hit them all? I don't even remember. I always love to go to Google for stuff like this. States, U.S. states that begin with an M. All right, Massachusetts, Michigan, Minnesota, Mississippi. I didn't have Minnesota, or I didn't have any of these. I didn't have Massachusetts, Minnesota, or Mississippi. Here's a list of states. So let's see how many start with M. 1, 2, 3, 4, 5, 6, 7, 8 states. So I need Maine, Massachusetts, Minnesota, and Mississippi. So I need Maine, and we'll put 4 of them per line here. All right, and we'll come down here, we'll put in Minnesota, and Mississippi, right? It looks like I'm still missing 1. So Maine, Maryland, Michigan, Minnesota, Mississippi, Missouri, Montana. What am I missing? Massachusetts. Yep. We'll do it like this, it'll be fine. All right, so there's my states, okay? And there's absolutely nothing wrong with what I just did. As far as I know, it's syntactically correct, but I have to remember when I do this, I have to remember that M states sub 0 is equal to main all the way up through the last one, which is M states 7, and that's equal to Montana. And there's, again, nothing wrong with doing that. But it'd be nicer, instead of doing it like this, if I had a better way to refer to these. And there is that way. So I'm going to put each one of these on its own line, just so you can see what's, so you can see what's going on here. All right? Because I'm going to have to make some changes. That's why I'm doing it like this. So right now, this is a numerically indexed array. but I don't have to make it 1. So I can come in here and I can say, you know what, we've got main. I think that's the abbreviation for main. Then I put an equal sign and a greater than sign, and I do it like this. And I'm going to just do this all the way down. I may screw up some of these because I don't know what all of these are. I'm going to say MA here. Again, I don't have to have blank spaces in here. I've just put them in there for hopefully a little bit better readability. Well, Maryland is, I think, MD. Massachusetts, I believe, is MA. Michigan, I believe, is MI. Minnesota, I believe, is MN. Mississippi, I believe, is MS. And I could be wrong on some of these, but I just want you to get the idea. Missouri, of course, is MO. And finally, Montana, which I believe is like MT. But the difference is, and what I'm showing you right here, is now when I want to refer to Michigan, I don't have to worry that it's 0, 1, 2, 3. I can instead, I can say M states, and instead of putting a number in here, I can now say MI equals Michigan. So that is what's referred to as an associative array. So we're not indexing the array numerically as we've looked at before. All right? So an array whose elements are referred to with an alphanumeric key, which means they can contain letters or letters and numbers, rather than just a straight number. All right? Again, typically you do this because it makes your code more self-documenting. Okay, so caution, yellow. Otherwise it would be 1. Stop here would mean red. Otherwise you'd use 0. Go here would mean green. And otherwise you'd use 2. So you do this again to make your code, at least in most people's opinion, a little bit more self-documenting. And there's a lot of different ways that you can do this. All right? And I should say more than that, there's a lot of different uses for this. All right. Okay. Let's jump into here. Creating methods. Now we're talking about creating methods for our own objects. And a method is simply a function that's within an object. All right? So the 2 ways as mentioned here that you can add a method to an object. You can either provide code for a method in the object itself, or you can reference an external function. All right? So here's an example where this is an order object because it's in the curly braces. And inside of here, we're going to have both an object called items, and we're going to have a function in here that's called generate invoice. It's going to have some code in it. But if you want to, you can take the function and declare it outside of the actual object, and then reference it in here. And notice when you refer to it in here, you cannot use parentheses. All right? So a natural question might be, well, which one's better? I love that when people ask questions like that, and then you're given an answer like, well, that's like asking who your favorite kid is. The one that's better is the one that makes more sense to you. That's the one you should use. All right? when you create these custom objects, if you want to work your way through the object to see everything it has, it's called iterating your way through the object. And in order to do that, one of the ways, you can use a regular for loop, but you can also use a special JavaScript loop that's available in other languages also, that's called a for-in loop. In some languages, this is called a for-each loop. All right? But it allows you to enumerate or walk your way through an object. And you can use it like this. So what this will do is it will go through the entire object. It will go through each one of these properties, run that if statement on it. Okay? Well, if you want to be able to create your own object, you want to be able to delete your own object because maybe you're not using it anymore. All right. So in order to remove an object, you use the delete operator. Okay? You can use that to delete properties. Okay? And I believe if you set an object equal to null, so if I say the name of the object equals null, I believe what that will do is that will basically say, okay, I'm not using this object anymore. Garbage collector, next time you come through, please, you can release this memory that's being used for this object because it's not needed anymore. All right? We talked a little bit earlier about constructors and what a constructor function is. As it says there, it's used as the basis for a custom object. It's also known as object definition. JavaScript objects inherit all variables and statements of the constructor, and all JavaScript functions can serve as a constructor. So here's an example. All right, if I create an object called order, I can make my own constructor in there, and the constructor has the same name as the object. And you see the word this in here. And it's just a shortcut, so you don't have to say order dot, because sometimes the name here might be really big. You always use the word this. That means the current object. That's what it means. That's what the word this means. It's a key word in JavaScript. It's used in Java. It's used in a lot of other programming languages as well to mean the current object. All right. So you can come in here as it says, and you can create a function to use as an object method. So in other words, you can create your own methods, which would make sense because if you're creating your own objects, you'd want those objects to have their own methods on them. And again, we'll go through examples of this in the classroom. Sometimes though, you come in and you've created an object, let's say you come in and you create an object, and then you create another object that's just like the first, then you create another object that's like that. So let's say that I created a bunch of objects for all the members of my family. So I made a Jeff object, and a Sandy object, and a Taylor object, and a Mackenzie object, and a Chloe object. So I made those. And now that I'm done, I forgot that, you remember, objects only have the abilities and powers, so to speak, that you give them. So I gave them an eat, and I gave them a sleep for each one, but I didn't go back and I didn't give them a drink. So right now, none of my person objects can drink. All right, I could go back and manually add it to each one, or I can create what's called a prototype property and have it be created and then shared by all objects. So typically, you use the prototype property after you've already instantiated one or more new objects and you want to add additional properties. That's what I'm mentioning to you right now. By default, that new property is only available to that specific object, but you can set it up so it's available to all objects of that type. So as it says, object definitions can use the prototype property to extend to other object definitions. All right. Now that may or may not have made a lot of sense. And remember, you're just learning this stuff. When we go through the examples in a classroom setting, it'll probably make a lot more sense to you. So in this chapter, we started out with some of the fundamentals of OOP, or object-oriented programming. We talked about its reusability. I mentioned the fact that it's modeling. We talked about objects and how objects are called components. They're really instances of a class, but since JavaScript is object-based, we don't have true classes in JavaScript. An object, as mentioned here, is a programming component, so it's got code and data. They have equal importance, okay? Objects are encapsulated, and we talked about encapsulation and information hiding. We talked about an interface, and I also mentioned the word implementation. The interface is what you show the outside world. The implementation is the code that you hide from the outside world. Again, we talked about information hiding, and I mentioned putting your car in reverse and not really knowing what's happening under the hood, so to speak. We talked about what classes are, what instances are, how an object inherits the characteristics of a class. All right, we talked then about some of the built-in JavaScript classes, the date class, the number class, and the math class. And finally, we came back and we talked about how you can create your own custom object. And when you do that, the use of the this keyword and the prototype property. So that's it. That's it for Chapter 7. When I come back again, we'll go into Chapter 8, which is on manipulating data in strings and arrays in JavaScript. So I'll be back with that chapter shortly.